Hello, welcome to the Shelly Show. I'm Shalendra, and you're watching the simulcast live on LinkedIn, Twitter, Facebook, and YouTube. Hope you're safe and maintaining social distancing. A very important aspect of artificial intelligence is the ingestion of information into the machine. Primarily, there are three different ways of ingesting information: video, audio, and text. Computer vision allows us to ingest visual information to be ingested and then processed. According to a market research, the computer vision market is valued at around about 12 billion US dollars and is likely to reach 18 billion US dollars by 2023, growing at a CAGR of 7.8% from 2018 and to 2023. In today's episode, I have three very special guests who have been working on computer vision for the past few years, delivering many projects. I'm sure you're going to learn a lot from them. So here is your opportunity to ask them questions directly. Please write your questions in the comment section and we will take them. My first guest is Abinaya Seenivasan from SAP. Abinaya is a data scientist with a demonstrated history of working in computer vision and natural language processing. One of her notable works in computer vision is an application for visually challenged to recognize currency, which can run on a low-end smartphone with 96 to 97% of accuracy. So let me bring her into the show. Here we go. Hi, Abinaya. Welcome to the show.
Hi, Shelly.
How are you?
Yeah, I'm fine. How are you?
Very good. Okay, let me
It's
bring
great to be on your show. Yeah.
my second guest is Aruna Kolluru, who is an emerging technology specialist at Dell Technologies. She has over 19 years of experience in industry, working on various technologies and roles including AI, blockchain, deep learning, computer vision, IoT, big data, and information management. I've run out of breath. Okay, so let us bring Aruna into the show. Hi, Aruna.
Hi, Shelly. How are you?
Welcome to the Shelly Show.
Great to be on the show.
Yes, and we will crack on. And finally, I have Dr. Nick from SAP. Nick is Dr. Nick, as we call him, is a passionate technologist who has been architecting and developing market-leading software applications for the past 20 years. Nick regularly presents at universities and conferences on digital transformation and disruptive technologies. He has a PhD in computer science from Monash University, and let me bring him on. Hi, Dr. Nick. How are you doing?
Good, Shelly. Thanks for having me on.
Very good. Welcome to the show. Perfect. Okay, guys. Very quickly, for you to view this episode and other sessions that are on emerging technologies live, I would request you to follow me so that you can be alerted when a live session is on. This gives you an opportunity to ask direct questions to the guests. So please press the follow button on LinkedIn and Twitter and subscribe button on YouTube. That's on. And now let's get on to the content, the meat part of it. Computer vision. So guys, first of all, can you explain to me what computer vision is for a layman? Who wants to go first? Aruna?
Yep.
Okay.
Computer vision is just about how we see. We normally see with our eyes and we don't give much thought to how we actually see, right? There's a lot of processing going on in the brain. If you think about it, just to put it in perspective, about 30% of the brain is actually used for processing visual information, whereas only 6% is used for hearing. So giving the ability for the machines to see and perceive like humans do, that's what computer vision is.
Okay. Dr. Nick, you want to add something?
I think Aruna's done a great job in explaining it. I mean, definitely the complexity of understanding what we see, making a computer look like we do and identify characteristics in the area that it sees is currently that view, and everything from autonomous cars to being able to identify different products and labels is kind of where we're heading. So definitely keen to explore more on this topic and subject.
Okay, guys, I must say, well, to your point, I think, Dr. Nick, I think artificial intelligence is mimicking human intelligence, and one aspect of that is ingesting information, and as we all see, humans see, so the computers and machines need to see, and that's, I think, in my view, that's computer vision. Abinaya, you want to add something to it, or?
Yeah, exactly like you said. So it's like when you see the picture of flower, you immediately know that that is flower, right?
Yeah.
So it is like teaching the machine to understand, like mimic how the our brain thinks. So that is what the computer vision is. So teaching the machine to understand the picture which you are seeing is a flower, something like that. Yeah.
Okay. Um, Tell me, how is computer vision changing our lives? So who wants to go first? Dr. Nick?
Look, in our modern world, it's changing our lives dramatically. You're seeing everything from computer vision being applied to autonomous cars to currently what we're seeing at the moment in health and safety areas, right? To me, computers being able to help us identify and view things is changing everything. Even the way, doctors, for example, the last articles I've been seeing is, using computers to identify tumors in people. So that's the computer obviously being able to, scan through an image based on the I guess the size of the tumor, the characteristics of the tumor. We can then reuse that model across other things to then identify different kind of tumors. And where we started this off with breast cancer and some of the other areas, we're now applying it to a lot of areas of medicine. I think the most recent one I saw was to be able to identify like plaque in the brain for people that have Alzheimer's. So, I guess we're only in the infancy of understanding what we can do with this piece of technology.
Aruna, you want to add something to it?
Yeah, like Dr. Nick was mentioning, there's a huge potential, right? We're just scratching the surface right now. We can do a lot, right? So it's actually extending into other things, like the new use cases I'm seeing is actually with the thermal cameras, how we can detect the temperatures. That's been everywhere in airports and everywhere they're doing that. But also, like Dr. Nick was mentioning, with detecting the tumors from the X-rays and images and everything, it can be extended into really scanning as well, right? The scanning with a thermal camera, not with the actual radiation and X-ray machines, right? Scanning that and detecting and diagnosing.
Okay. That is good. Thank you. Sorry. And Abhinay, you want to add something to it?
Yeah, so yesterday when I read an article, there is in like we can use a computer vision to identify in a crowd like who is wearing mask, and nowadays it's really important to wear mask in a public. So you can also view whether the people is wearing mask or not, and then you can alert them. So it can also be implemented in like workplace safety, or like say you said in healthcare, it's a great help. Like especially like for the tumor, identifying the tumor, and it could be applied to all the industry, you name it, whatever the industry it could be the agriculture, or it could be supply chain, or whatever industry, it will be a great help. And it, yeah, so that's what.
So in that, let me extend that a bit. So in the COVID scenario, computer vision, and Aruna, you mentioned about masks. Computer vision can actually help a lot in that. What do you think about that?
Yeah, we can actually detect mask, like Abhinay was mentioning, and also look at the distance between the people, right? In a public place, how do we actually see what's the distance between multiple people? And also the density of the room or a conference hall or something like that. Like if they're actually supposed to be 100 people in that room, do we have more than that? How do we alert them to say that they have to leave the room and make more space or maintain that social distance, right? We can measure the distance. We can actually look for masks or any protective equipment in the hospitals, right? Whether with the nurses or the doctors, they might actually forget in a hurry, right? They might not wear a glove, or they might not put the mask on or something. If they forget, we can actually alert them and see. I've also heard that they're actually using to check how many times they're washing. They're really using the sanitizer, right? Like the number of times they're using the sanitizer and reminding them to do that. So multiple checks at the hospitals, especially with the COVID stuff, it can be really helpful.
Okay. So what is really driving the adoption of computer vision? So Aruna, can you explain that as well? Why are people getting into that space now? I know AI is driving a larger component of that, but is there anything else also driving that?
Yeah, well, the reasons have been very different till now, right? We said the increase in the data, the number of images are increasing, and there's actually an estimate, I forgot the number, right? It's a huge number of images we take every day. And in the whole zettabytes of data in the world, 90% of the data is actually pixel data, which is images and video. There's a lot of insights in that. And we were talking about how there's increase in data, algorithms themselves and the hardware were the reason for the spike in the adoption of computer vision, or rather the whole AI itself, like you were saying. But now with COVID-19, it's very different, right? As the world is actually recovering from this global crisis, we'll be seeing more adoption of computer vision and AI use cases. So every business is actually looking into what affects their bottom line. They're actually looking to automate the tasks and how to create higher operational efficiencies with this, how to reduce the workforce exposure to any infectious environments, how to make fast and efficient decisions in terms of crisis. So actually see the adoption will increase in the next few years with COVID.
Okay, so don't you think, Dr. Nick, that is also due to the fact that organizations and systems want to reduce the human intervention, and I think this was one area where we needed a man to actually have a look at and describe stuff in the past, and now this is changing?
Well, the way I look at it is, for me, computer vision helps augment human capability. In other words, it facilitates it and makes it better. So, for example, the earlier example I gave around doctors and being able to identify tumors, we found that, when you use machine vision or machine learning to identify tumors, where doctors were 70% accurate, the machine was 96% accurate. Right? Yep. So so what that will allow us to do is actually give people more quality time. So you let the computer vision run through the image to identify the scan, and that way the final decision is still the human, right? The human is still saying, the doctor is saying, based on everything I see, based on all the characteristics this vision has provided me, then I can comfortably say that this is a tumor, and then I can take actions. Where previously the doctors would have to go through and try and scan all images, where now a computer can do it in seconds. So what we're doing is actually becoming more efficient. We're allowing people to spend more time doing high-value tasks rather than these low-value tasks of searching through. And the same can be applied. I know I've obviously used medical, but another area which we focus heavy on is in utilities. And I know, previously, the way utilities works by using big helicopters to fly over, take huge megapixel cameras to take images and identify when there's when there's certain greenery or vegetation management have crossed the lines. Now they do it in sub-seconds because they take the photos, it gets pulled into a computer, and a computer vision program goes and identifies where there's different overlays on vegetation, and so that now allows these utilities people to now focus on making sure they've got quality, or they're maintaining their maintenance on their assets, rather than sitting there and have to do this vision. So I actually look at it as complementing and giving humans to spend more time with humans, and letting machines doing the mundane tasks that humans don't like to do.
Okay, that is very well said. I think what you guys have mentioned, a lot of business cases and lots of cases where I want to know what are the day-to-day consumer cases that where computer vision is helping. So let me put that question to the audience. So audience, guys watching, there are more than 40 people watching at the moment, 43 to be sure. Guys, is there any area where you see computer vision is making a change to your lifestyle? Of course, there are phones, there are cameras in the phones. So where do you see where there are changes that are happening in your lifestyle due to computer vision, as we've just described what computer vision is? So that is the question for the audience. And if anyone of you want to take that question, guys, please go ahead. Dr. Nick or Aruna or Abinay?
Sure. So like we all, it's changing every part of our life, right? We wake up in the morning, and the first thing we do is actually look into our phones. We authenticate with our Face ID. That's computer vision, right? We check our social media and the pictures and everything. Our faces are tagged, and we recognize people. That's computer vision. We eat our breakfast, and the food actually that might actually coming onto our table might be managed using computer vision, right? The farms are managed using computer vision for their health and maintenance. And then we get into our cars. Again, it can almost all the new cars actually can detect these lanes. That's computer vision, right? With lockdown now, we're using Zoom and all these things and the virtual backgrounds. That's computer vision. So every part of our life, there is actually computer vision there. So it's changing more and more each day.
Okay. As the audience thinks about more such more such use cases which they see in their lifestyle, let's go to the next question. What are the technical components involved in computer vision? So what is it? Is it a camera? How do we go about it? Who wants to go? Abinay, you want to go?
Yeah, so primarily it is a camera, so wherein we capture the image, and then we use the machine learning algorithm to identify, to teach the machine to understand the picture. So we will be using machine learning, especially if you go into the machine learning, we'll be using convolutional neural network. So if that's what you are asking about the technology, yeah, those are the technologies we'll be using for the computer vision.
Aruna, you want to add something to it?
Yeah, like Abinay has mentioned, camera is the biggest sensor here, right? Which is actually capturing all the data from the world and creating these images and videos, and we bring it back, right? There's two parts of it. Like Abinay was mentioning, one part is actually to teach. That really happens at the data center, and convolution neural networks are the ones which can understand it. And then we bring it back. Once the machine model is trained, we bring it back to the edge, maybe on a phone or on a device, on a camera again, and then which can understand. That's the AI deep learning part of, or the AI part within the real understanding, right? Like when we actually put it at the edge.
Okay. Dr. Nick, what do you think?
I thought you. So this is an example of computer image, right? So what I've actually done is I've downloaded the snapcap filter and applied a different setting. And what that's actually happening in real time is, obviously the camera's identified who I am, and then it's put an overlay, obviously using algorithms. And this is some of the things which people are using at the moment to basically, I guess, consumer facing, but make it more entertaining. And I know I'm also using it in business because I have a bit of fun. Sometimes I'll rock up to a meeting with a different kind of skin on, just to make people smile and have a bit of a laugh. But you can definitely do all kinds of weird things. One of my favorite is obviously the potato. That's me now as a potato. That's because I spend a lot of time in the country, so I pretend to say I'm a potato. But as you can see, this is where we're applying it in consumer world and entertainment world. And where we're seeing a lot now is obviously the modern movies, where we're using different skins and things to overlay and make things look human-like. But then there's also, I'm talking about the positive things. The other, I guess, challenges and the other worries that we're seeing is the concept of deep fakes, right? Where we have someone, look like they're saying something, but what they've actually done is they've grabbed video, image, and models of this person and then retrofitted them into another person. So it looks like this other person is saying. And this is, to me, going to become a real challenge, because then how do we identify what people are saying are real? What did they actually see? Has it been augmented? And I think we have to be very cautious. I think we have to put some right governance in place to make sure that that's all done properly.
Good stuff, Mr. Potato. That's a good one, and my daughter loves Mr. Potato from Peppa Pig. Anyway, so coming back to that, that's you talked about the deep fakes that are happening these days, where people are the one with Trump's photo and Obama's photo and Obama's video with Trump's voice on it. I think that was doing the rounds a few months ago. I think that was something very, very scary as well. So we don't know what is true, what is right, what is wrong, and we can't even think about it whether whatever is happening is true. Whether what Dr. Nick is saying is what he's saying, or is someone else saying for him.
Correct, yeah. And for me, that's a real challenge. And And that's where, I mean, we talk about computer vision, but I think we also need the right ethics and guidelines around it to ensure that people don't exploit or, you know, take advantage of these computer vision. Because you could basically set people up for anything. You know, you could pretend that your car, you know, went through a red light and you get fined, and you go, well, no, I didn't cross a red light, and they go, here's a computer vision that says it did. So for me, you know, there's these really fine boundaries, and we need to make sure that we have the right, I guess, legal framework in place to ensure that people are protected, and you know, things aren't people aren't taken advantage of through these kind of systems and solutions.
Yep, absolutely.
Yeah.
Yep, Aruna, you want to add?
Yeah, to add on
yeah.
to that point, so it's like for the face recognition, especially in some offices, they have the face recognition in the security to enter into the building, right? So I even read that some research is going on, like you can actually do some makeover like some other person, and you can still get the access to enter into that building. So these are all the things where we draw a line, and like we have to introduce some regulations to avoid these kind of things, and even some research is going on, like how to actually identify whether this is a correct person I'm allowing an access to.
Okay. Good stuff. And I think that also reminds me of an app, a TikTok app, where you can actually put, every time they do a new computer vision animation along with you, where you have to do some contest. I think, Abinaya, you're of that generation. Maybe you can share some of that. I'm too old for being
No, I'm not a TikTok user, so I didn't get it.
She's sensible. Abinaya is very sensible. She's really good.
Yep. Okay, stuff. Good stuff. So next question. No, let's look at some use cases. Let's talk about use cases that you've talked about a few, but let's deep dive into them one by one. So how's computer vision being applied in traditional business operations? So normal business operations that happen, what are the kind of use cases do you see? Aruna, you want to go first?
Yeah, it's really disrupting across industries, right? It has the ability to understand and perceive the images and videos. So we spoke about healthcare, security, automotive, retail, manufacturing, media, finance, agriculture. So actually, you know what? I cannot think of an industry where computer vision is not really applicable. It can be used to enhance productivity, efficiency, customer experience, reduce the operating costs, minimize the defects, improve security, and a lot more. But first thing that comes to our mind is actually surveillance, security, autonomous cars, and all these high-tech industries. And then we add drones to it. We think about defense, border security. But something as humble as agriculture is really embracing computer vision and all these emerging technologies, right? So the Food and Agricultural Organization of UN, it actually estimates that new emerging technologies like IoT has the potential to help increase agricultural productivity by 70% by 2050. So there's actually a great need for agriculture, and they're also adopting this.
So let's focus on agriculture itself. So is there a specific use case that you guys are aware of that we can talk about? Abinaya, you want to go? Or Aruna, you want to go?
Yeah, so,
Abinaya.
okay, Aruna, you go first.
Yeah, so agriculture industry is actually using computer vision for everything, right? For planting, weeding, harvesting, disease and health detection. So drones, along with computer vision, really play a key role in agriculture and farming. So autonomous drones capture this large amounts of data for detecting and training. And this data or the images are actually converted to a map using photogrammetry. And this map can be actually then used to detect the diseases, pests, poor plant nutrition on the farms, and used for selective herbicide and pesticides there. So it can also be used for livestock, right? To recognize the livestock, count them, monitor them without really any humans. So there are plenty of them, including precision farming, right? Looking at the data in the images along with the other sensors like moisture levels, soil conditions, weather conditions, and the past patterns to really identify like what is needed and do precision farming. I was also talking to someone from the agriculture industry, actually the technical industry in agriculture, technologist in agriculture industry, and he was mentioning they can tweak the nutrition levels in the plants, right? So if you want more iron, they actually need more light, or if they need larger leaves, they have to change some factors. So with this vertical farms and hydroponics, there's a lot happening there, and tweaking the food to produce more, to feed the whole world, and also produce the right amount, right kind of food.
Okay, and that all
Making
by
it easier.
taking a picture of the plant?
Sorry?
I said all of that by just taking the picture of the plant or taking a video of the plant?
Yeah, so some parts are actually pictures, some parts are videos. So we can actually send a drone across the farm, take the pictures and convert it to a map, or even take a video and then convert it to a real live 3D map kind of a thing and compare it.
Okay.
Yeah,
Okay.
depending on what we have, we can actually use it. There's no one way of doing things. We can use anything.
Okay, good stuff. Any other industry that you see, Dr. Nick, you want to talk about?
Yeah, sure. Maybe what I'll also do is maybe play a video so that the audience knows what we're kind of talking about. One of the examples I've seen, and it actually won an Innovation Award, there's a local partner here in Melbourne called BornDigital, and they developed a particular solution for a large miner. Now, this miner, what they had is they had a lot of challenges and issues around what they call asset maintenance, right? So whenever there was an issue with a truck, they'd have to try and identify the truck, then they'd have to try and post it in, and then get some certain insight and information from that. But what the team at BornDigital were able to do was able to use the capability in the iPhone. The iPhone's got some capabilities to process using Core ML, the kind of truck, be able to identify the number plate and reading, and then just using, they could either type it in or use their voice, and then create a notification. So something which would normally take up to 20 minutes to half an hour to try and do, using an iPhone and the computer vision capability, it's now done in a few seconds. So I think that's a really great example of how it can be applied.
Do you want to play the video again, just so people can view that again?
Sure, yeah, because it happens really quick. So the whole idea, it's identified the number plates, and as you can see, it's looking at it. So LV, it's actually reading, not so much at the top. There's an asset number, and that's how it's being able to identify. So using the image classification to identify the asset number by the picture at the top, and then obviously they typed it in, but you could use your voice to explain what the issue is, and then create the notification. So again, this is taking a business process that would normally take 20 minutes to half an hour. Sometimes it'd even get lost, right? Because what these guys would do is they'd write it down on a notepad, and by the time they take it back to a computer and type it back in, it would be really painful. But now, thanks to computer vision, it's done in a matter of seconds. So,
Okay. Abinay, you want to share any use case that you see?
Yeah, so when Dr. Nick showed that video, something popped up in my mind. So you can have these cameras in the traffic lights, and then you can scan all the vehicles which are going through that way. So let's say if some accidents are happened, then in that case, you can track those number plates, and then you can chase it back, or you can immediately raise an alarm to the ambulance nearby so that it can come and treat the patients. So in those cases also, the computer vision will be of great help, especially in the surveillance, or it could be of anything. Like I said, it can track the vehicles, and it can track it can alert the patients. Ambulance, yeah. And if you talk about the industry,
sorry. I was actually asking the same question which you are now going to answer, and I'll come back to you. So let's go industry by industry. So which is the industry where there is more computer vision being used than the other industry? So is there any one industry which is doing better than the others? But before you answer that question, Abinay, I must say that there are more than 40 people watching. Guys, if you've got a question, this is your time to ask the question, and I will definitely take that question on. So please mention your question in the comment section, and so that we can take those questions, because very soon we're going to go into Q&A. So please ask your questions in the comment section and we will take them. There are guys, you must know that you've got around about 40 people watching it at the time. So please, guys, put your question in and we will take them up. Abinay, your question around whether it is one industry better than the other. Which industry do you think, or have you seen, is utilizing computer vision more than the other?
I won't say that one particular industry is using more than the others. I'll say that collectively, almost now, all of the industries are, especially if you take healthcare and surveillance, and then even the supply chain, everywhere it is using. So I'm not mentioning any particular industry here that is being used more than. I mean, that could be the surveillance, because that's where the camera is the primary thing. And I think even the supply chain, they have the major use cases in the computer vision. Like they can see what are all the how many stocks are there, and if any products are damaged or not, and if the products are aligned or not. Even if the products are out of stock, it can alert the supervisor immediately before going to that. And it's not only just, it's even you can have the workplace safety. Like you can continuously monitoring the employees and what are they doing. If some truck is moving towards them, and we can alert them immediately, so that you can basically identify the distance between the person and the truck. And you can see if it could be the construction industry, you can see whether the person wear all the work protective equipments before entering into the area. So it could be, it's like a wide area wherein you can implement the computer vision more. So if you want me to talk about any particular industry it's being used more, I could say that could be the surveillance, wherein you can monitor and you can alert the people whenever necessary.
Aruna, which industry have you seen where computer vision is being used more than the other? Because all three of you will have a different point of view, I'm sure, because there is no one industry that is doing better than the other. But it's what we are exposed to and what we see is what we can talk about. So Aruna, which industry do you think is doing better than the other, or is utilizing computer vision more than the other?
So like Abinaya mentioned, right, like surveillance and security is the top one, right? Everyone is actually using that for security. Different industries are using it for security. But other industry, I would say, is actually retail, right? Retail is really using it to check who is coming to the store, what age they are, what gender, age, emotion, which parts of the store they're actually moving into, which parts of the store are really being utilized more. So how do they actually arrange the whole store based on the number of people moving, and also to check how many people they will need to serve these customers at a particular point of time, looking at the patterns at different times and all these different things. Retail is another big one, and Amazon Go is actually a great example, right? After the Amazon Go, everyone is actually trying to replicate that. Auto checkout, where how do we actually make the machine look at the items which we're buying, not really allowing them to check in a red apple as a green apple, or avocado as onions, right? I heard one of the largest retailers actually sells more onions than they buy, because they actually convert themselves into avocados.
That's a good one. Dr. Nick, what's your point of view on that?
Yeah, look, I mean, both Abinaya and Aruna have brought up some great examples. And again, for me, I've seen it being applied everything, even from our postal systems. Like I know I was working with like one of our, obviously, Australia Post, and how they use it to, identify where your mail is going. And I think it's up to 90, I think they've got up to 96% is actually managed by computer, right? Even if it's with bad handwriting, they've tuned the algorithm so well, it can route it accordingly, and there's only like less than 10% human intervention. And I guess that goes down to supply chain. I know Abinaya mentioned supply chain before, and actually this is an example which she told me, is the using drone for stock take, right? So having the drones fly through and do stock take in a warehouse, and I've seen many examples of that. It's I think now it's with us no matter where we go. I mean, I even look at now our iPhones, right? For me to be authenticated on my phone, it knows who I am, and it says, yes, I will now work, because I know that you're the one accessing your phone. The only challenge is we need to reduce or have reduce bias and have a greater understanding. And I'm not sure if people know, actually, one of the funny stories of when Apple first released Face ID, they released it in China, and there was a lady and her colleague, and her colleague was able to unlock her phone with her face. And the reason is they obviously hadn't done enough bias testing, because they hadn't checked to see, obviously the characteristics that are in a Western face probably aren't as common as the characteristics in an Asian face. So for me, for us to really expand and grow in this area, we need to have greater diversity in people working this team. And it's great to see, actually, even with this call, we've got 2 males and 2 females, so a bit of a balance of diversity in that sense. But definitely we need more, people from different areas, different backgrounds, because everyone will see things differently, and the way we characterize and classify things, and the more input we have to kind of grow our algorithms, and the better quality information that will get produced. So that's my view on things.
And talking about cameras and facial recognition, it reminds me of the great iPhone 10 launch, when they went onto the stage and it couldn't unlock the phone for such a long time, and then they said, okay, we'll do that later.
Yeah. And it might have been because of lighting, right? They didn't test under those lighting conditions to pick up the face, and it's just small things like that, and that's why you need, as I said, I think the greater diversity, the greater amount of people we have in here inputting into what computer vision should look like, then the better results we'll get. I think one of the another example which I have, which is unfortunately a sad one, was the example of what's called Tesla and their what's called their self-driving Volvo cars, and unfortunately there was a fatality in this instance, and it's because the machine identified the person trying to walk a bike as a bush, and because it thought it was a bush, it didn't think of, and unfortunately, because the person quickly moved then from the footpath onto the road, it ran them over, right, and the fatality happened. Had it identified as a person walking a bike, then that wouldn't have happened. So there's so much, and that's why I'm still very skeptical in jumping into an autonomous car. What you need to think about is that's your car trying to see, right, and it's all depending on the people programming it. On what it actually sees, and if they haven't given it enough data, enough information, then the result could be deadly. And that's an example of what we saw in this instance.
Yeah. So guys, you've mentioned a positive use case, Dr. Nick. You also mentioned a negative use case where it could go wrong as well. Before I come to my question around the most innovative application of computer vision, in your opinion, and that is what I need you to think, I want to ask you another question, and that is, but before even doing that, I'll ask the audience to ask the question again. So audience, you've got a question, please ask now, and press the subscribe button, the follow button, and so that you can get all such videos and learn from all the experts here in the future as well. Where is privacy in all of this? So are we all, you just mentioned my phone knows about me. Is there a privacy violation somewhere? Who wants to take that first? But please keep thinking about the most innovative application of computer vision. And we will ask that question to the audience as well. Dr. Nick, you want to go for that?
Yeah, happy to do that one. I guess with the iPhone, the good thing is that, and the way Apple have done the privacy, is that the image characteristics or your classification of your face stays on the phone. It doesn't get sent to the cloud. So you don't have to worry about your image being sent somewhere and then someone using it then to unlock several things. I think Apple have done a really good job in their instance of how they've managed to keep it secured on a particular device. But privacy is definitely key. I was speaking to one of the people at I guess Transport Victoria, or public transport, and they were looking at using, or basically not having tickets anymore. right? The minute you step on the train, it sees you, it knows who you are, it starts charging you, and it can see how long you've been on the train, then get off the train. The challenge is then privacy. And they had to move away from it because they'd have to store that data of you in the cloud somewhere, and that can be processed. And the challenge is if that gets hacked, then someone else has that critical information about you. And so, companies, so for example, like ourselves at SAP, we are what we call, GDPR compliant. We were one of the first companies in the world to be GDPR compliant. We do several audits and checks, every year to ensure that we meet that certain level of privacy. And I think that's something people need to worry about, and I also think it's a bit, I also relate to this new COVID tracing app. People were all worried, there's this app that we're going to have to install that knows where we are and everything. But if you think about, people are using Google Maps, people are using Facebook, people are already sharing a lot of their private information, probably more private information than that COVID tracing app. So I think people just need to be mindful of the information that they're sharing and what's publicly available.
Okay. What do you think, Aruna, about this? So is there a privacy violation happening somewhere? I used to say, and this is my comment, that in today's day and age, privacy is a myth. Because you walk out of the home, there is a camera looking out for you, and it will figure out who you are, where you come from, what you do, and if they match it right with the database, possibly they can track me wherever I go. What do you think, Aruna, on this? Hi, Aruna, can you hear me? Abinay, Aruna can't hear me, so do you want to?
Yeah. So, like I said in my previous example.
So, as a I can. So,
It's a lag, I guess.
Okay. Aruna, go for it.
Can you hear?
Yep.
So, yeah, sure. So, as a technologist working in this space, right? Like I really see the positive impact these technologies can do to this world. Like we were mentioning, whether it's in medical industry or agriculture industry or defects in manufacturing, supply chain, there's lots of positive things it could do. Like any other thing, there are negative things we can do with this as well, right? It's really depending on how you want to look at it. It depends on how you want to use it. There's a whole field of AI called ethical AI, which is being built around what we can do and what we should do, what we cannot do. That's one part of it. In terms of privacy, like Dr. Nick was mentioning, there's a lot of people who are sharing more information on their social media sites than what they are supposed to. But you have to really balance, right? Like what do you want to share, and what is the impact if it can save someone's life, or it's actually for the security and safety of the whole city and us, then we should really think about it. And there's other part is actually about dealing with this data, like any other data. How do we actually secure as developers? If we are looking at a face recognition application, do we really need that face to be stored, or can we redact it? Can we actually store just the facial encodings, right? So how do we save that information is also really important. What's required and what's not required. So for every project or every application which we are building, we need to think about the different ways of how we store, how we maintain the privacy, what's necessary, what's not necessary.
Okay. Abinay, you want to add?
Yeah, so exactly like Aruna and Dr. Nick said, I was mentioning the same only. So nowadays, all the government, they have the PDPA guidelines which have to follow. So every companies, whoever signing up, collecting the personal information about the people, they have signed up this guidance. Probably this guidance will help us in avoiding the situation, especially in the privacy concern, because all of them won't have the access for everything. They will have the information what they want. So especially in the surveillance and also if they are collecting the information about the car, like I said in the previous example, you can track where the car is. I mean, where the person is now from, like at this time he was in this signal and at a half an hour he was in next signal. So you can actually track the person, that is correct. But at the same time, you can protect those data. You don't have to store all this data. Like Aruna said, you can store whatever the information which is required, the timeline and the number. and it won't be given access to all the person whoever accessing it. It will be used whenever necessary, and under the PDPA guidance you can avoid this as at least to some extent. This is
Okay.
what I think.
And I think you're right, but in all of this, one thing is clear, that cloud and edge will play a very important role going forward, because if you have something that you've taken a picture of, and if you can't match it back where the repository is to identify what that is, then there is a problem. But having said that, you need to be looking at the edge, that some kind of processing needs to be done at the edge to identify whether that's a bush or a human, so that it doesn't just crash into the individual thinking about that's a bush. So it needs to have a balance between the edge computing and the cloud computing at both of these levels in order to make sure that we are doing it right. What do you think about this, Aruna? There's a lag is there, Aruna? Okay, Dr. Nick, what do you think?
For me, I look at this, very pragmatically. I think, and especially with our partners, Dell. I mean, Dell, I'm not sure if people know, and especially for our customers and people out there, Dell and SAP, Dell has actually the rights to use SAP's edge-based processing on their access points and routers. And for me, where I've seen some great examples of this is overseas. There's a big public transport company in Europe, and they're using edge-based processing to manage the maintenance of their trains. Mm-hmm. And this company spends, $1 billion a year on maintenance, right? And because we were able to introduce these edge-based processing, they were able to save 10%, 8 to 10%. So that's anywhere between $80 to $100 million by doing the processing on the edge so basically the processing happens on the train on these access points to help do that to do that capability. Now, I'm currently working together with the Dell team, who've been absolutely wonderful. I'm putting a vision together on how we can work together with telcos and provide the ability for edge-based processing, let it be in mining, utilities, even in smart factories. Because as we move forward, people want to be able to, we get large. One of the big examples I've seen is, in the US with some of the big shoe manufacturers, and being able to put 3D print a shoe so someone can have it delivered within 20 hours or 24 hours of them designing it. And for me, combining all these smart technologies, computer vision, AI capabilities, edge-based processing, we can get this done a lot quicker and a lot faster than what's been done in the past.
Okay. Now, very, very quickly, let me get to my final question before I get to Q&A from the audience. And that is, which is the most innovative application of computer vision that you've seen? Okay. So we start with Abinay.
So I will say about the invoice processing. So let's say nowadays, the processing the invoice, especially matching each fields with some other in the portal, that will be really difficult. It's a mundane task where the each person don't want to do it, and they have to spend around half of the 4 hours to 6 hours in that mundane job. But automating that is quite innovative, what I feel. So even I was working in one project, so wherein we have to process all the documents from the portal, and then we have to see which is PO invoice, which is not PO, and what kind of invoice that is. And you can even extract the fields from the invoice, and then you can process it with the help of OCR. You can process each fields, and then you can map it with a PO. So this is a big help, and then it has reduced around 70% of the manual work which the people are doing. So within, if you see, it has reduced 60% of the the efficiency is much more than the what humans are doing nowadays, because the humans would have slipped out and something, and they would have matched with the wrong PO. But that is the big help it's doing in a computer vision.
So can I extend that further? Does that also help in help by translating? Because there could be a language, because invoices are created by
Yeah.
people who
Yeah.
speak different languages. How does that work?
Exactly. So it can help in the language as well. It could be any language invoice. Like we can handle, it could be a Vietnamese or it could be English, German, French, whatever it is. It's just a OCR technology we are using. So it captures the image and it will extract the text from that. So that is a big advantage of using computer vision in those fields, because because generally what companies do is they will assign each person to handle different kinds of invoices. So, but you don't have to do with a computer, right? It can handle all kinds of invoices. So the language is the biggest barrier in computer vision when handling those invoices.
And what about the handwriting? Because
Hand,
chemists have a very
yeah.
peculiar handwriting, which not many people can.
Exactly. So the handwriting is a quite big challenge in handling the invoices with the OCR. So, but nowadays it's basically with the training, right? So for machine learning, you have to train those models in order to identify the handwriting text better as well. So it comes with a training of when on handling the handwriting process. But again, there will be some discrepancy when the handwriting is very bad, or lightning could be bad, and some overprinting may happen. If you see, if you're writing the handwritten, sometimes you will have the overwriting from other invoice. It will be the imprinted on the screen. So in those kind of cases, you won't be able to identify it accurately. But I'll say at least it, like I said, it's at least replace the 70% of the manual work which you do. Maybe in that case, it will give you an alert, and then you can just for those kind of invoices, you can have the humans to process it.
Okay.
Right.
Which is the most innovative application of computer vision that you've seen? Aruna, can you hear me? I think she can't hear us. Dr. Nick, your turn.
Yeah.
Oh, go Aruna. Oh, she's back.
Yeah, so we were talking about medical use cases and COVID and how to measure temperature and other things. But at the same time, think about non-invasive diagnostics in. Yes, I can hear you.
Yeah, keep going, keep going.
Can you hear me?
Yeah, we can. Yes, we can. Keep going.
Is it better now?
Yep.
So in hospitals, right, non-invasive diagnosis, how do we actually measure the stress, temperature? Yeah, how do we measure the parameters, health biometrics of the patients in the hospitals, right? Infections are the second largest cause of deaths in the world after heart attacks. So it's really important to really keep infections at low. So how do we actually diagnose or take these parameters, health biometrics, in a non-invasive fashion, right? Just have a camera before the patient and look at the blood flow, temperature, heart rate, everything just from the camera. I think that will be a really innovative one when we can actually achieve it in all hospitals.
But I think the extension to that was around during the COVID time. I think in China, they were able to, just take the picture of a person and say what temperatures he's running. If he's running high temperatures, then there was further tests to be required. Something like that was also there.
Yeah. Right now we are just like seeing temperature detection with thermal cameras, but it can be extended into many other things: heart rate, blood pressure, blood flow, stress. All this can be detected just from the camera and actually take these parameters continuously, right? So normally what happens is a nurse comes in and takes the reading every half hour, and there's no pattern, even though maybe blood pressure might be within the range, but we are not actually seeing the increase in the pattern, or the temperature might be within the range, but we are not seeing a decreasing pattern. How do we actually see these patterns when we get this continuous stream of data with cameras? That will be really helpful and innovative.
Good stuff. Before I go to Dr. Nick, guys, this is your last opportunity to ask questions. So if you can ask question now, I will take it just after this question to Dr. Nick. So Dr. Nick, which is, in your opinion, the most innovative utilization of computer vision?
Well, the one that I've seen probably to date, and I've probably got to be quick with this one as well, but the whole idea I saw as an example where they had and again, I'm combining several technologies here. They used a digital twin, a robot around a plant facility. Now, with this plant, the challenge is that, you know, it had a lot of its infrastructure underground in tunnels. Now, the incident which happened was that something had gone wrong, and you know, one of the pipes in the tunnel had kind of, you know, generated a whole lot of heat to the point where, you know, it was like plus 50, 60 degrees Celsius, and so you can't put a human in that possible area. So what they were able to do was send in a robot, and the robot could go in and perform some basic maintenance and tasks, right? And again, using, as Aruna kind of mentioned, using the infrared to identify where the heat's coming from, and then being able to repair it remotely. So basically, you know, taking a task which would normally be very manual and require humans with a lot of protective equipment, they were able to simply use a robot and a digital twin to image what was going on and then be able to fix it accordingly.
Okay. Good stuff. Yeah, that's an interesting one. Robots doing a lot of stuff. So let's get on to the audience questions. I have a few on, let's see, let's go one by one. On Twitter and YouTube first, and then Twitter, Facebook, and YouTube, and then we will go to LinkedIn. In the meantime, on LinkedIn, guys, if you've got a question, please put that there. I'll very quickly go through LinkedIn and YouTube. So the first message, it's from Bale Pandi, and he says, hi. Hi, Bale, how are you? The second one from Ekta Tuli, she's saying, hi. Hi, Ekta, how are you? Here is a question from Sujit Ramesh, and he says, can computer vision help me in my shopping? Who wants to take that?
Yeah, I'll take that. So
Okay.
yes, Sujit, the computer vision will help you in shopping. Like, let's say you bought something last week, and then you forgot that you bought, and then if you're trying to get something again, so it will notify you, hey, you already bought this last week. Do you still want it? I mean, based on the quantity you got it, so it can notify you whether like it couldn't be over, or you can have the group. Like if you have a family group, then it can actually track the family group as well, and it can say your wife already bought this yesterday, do you still want to get it, something like that. So, or it can give you some suggestions. So it can combine with the other technologies like recommendation technology, like in like you see in Amazon shopping, you will the user you bought it's already bought this, something like that. So it can also give you some recommendation in while you do shopping.
Anyone else wants to have a go at that?
I've actually got to jump. I've got a next call on, Shelley, but appreciate you having me on, and I'm sure you're in good hands with Abby and Aruna. So I'll look forward. Thanks for having us again.
Okay, thank you.
Thank you.
Thanks.
Okay, guys. Aruna, do you want to add to that? Hey, Aruna.
Yeah, with computer vision, right? Like if you're looking at, can you hear me?
Yes, yes.
Yeah. So if you're actually looking at, if you're looking at Amazon or any other major retailers, right? When you're shopping and buying, try to check for some kind of thing, right? A product like a shirt. If you look for a shirt, and then it actually recommends you people who bought this shirt also bought these other things, right? Maybe a pants or trousers or tie, but it's not really looking at what exactly is in that picture, right? If it actually looks at, maybe Shiley is actually fond of white shirts with a collar and so many buttons, it has to show you everything related to that. Rather, it actually shows completely different things because the items are not being tagged properly, right? They have been tagged by humans with a couple of things. Maybe it's a shirt and collar, that's it. They've actually taken a couple of things. But when you actually give it to computer vision algorithms to really label them, they can do it. They can do an exhaustive job, right? They can actually put in a lot of things and give you the right search results.
Okay, now I will add one use case to this, which is absolutely great use case, which I know from last 5 years, and that was the magic mirror. So in some of the retailers in the US, large retailers, what they've got is that when you go online, you buy and I'll take that example, extend that example from Aruna. You buy a shirt and you like it. So what you do is you put it into you save it, and when you go to a shop, you don't have to change immediately. You stand in front of a mirror and put that shirt onto you, and it will be like you wearing the shirt. And if you like that, then the next step would be for you to go into the change room and change it and test it out whether it looks good on you. But there is one other instance there. Apart from that, it can at the same time help you wearing other stuff along with that, maybe a watch or a tie, and you can just pick it and put it onto you without actually wearing it. So that is one of the great examples which I saw on computer vision, which actually blew me away, which was like great use case. Okay. Ramesh is still extending that. He's saying daily shopping is tough. How can computer vision help me to be better, more efficient in the way I shop? I think we've covered that a bit, to be more efficient. Examples. Let's go to the next question or the next comment. That's on Facebook from Guru Krishna Patnaik, and he says, checking in at airport with computer vision. Absolutely. Yeah, you go to the checkpoint, and all you need to do is show up. It will check your face, match it to your photo, and let you go. And I think that's a very good, very interesting use case. We encounter all the people who travel encounter that every time they go onto the immigration. Okay. Next question is from Samuel Victor. Hi, Samuel. How are you? He's saying, how do we eliminate bias in computer vision and AI and also address ethical issues and challenges? Aruna, you want to take it?
Yeah, it's like anything, right? We say garbage in, garbage out in this world. Like if you actually give a small set of data and you want to really look at the bias, it happens, right? For example, most of the age detection algorithms have been trained on white males. And if you actually give it a brown male or a female, then it actually completely goes wrong. It's because the data is not sufficient for it to learn. To give you another example here, Dr. Nick was actually mentioning earlier about Tesla. When Tesla released their cars in Australia, initially they had a problem with kangaroos, right? When the machine, it was not trained to see kangaroos, and when it saw a kangaroo, it was bigger than a dog and smaller than a cow. We didn't know what to do. It just panicked. But what they did was they actually trained it overnight and released the software. So here that's the benefit of using computer vision. You can add on more things and change the model as you grow, and remove that bias as much as possible. But again, the input data or the training data is really important here to be spread across multiple areas, so we actually don't have that bias.
Okay. Abinay, you want to add to this?
Yeah, like Aruna said, so you have to train the model using various out examples, something like you have to train with kangaroo or you have to train with dog, everything, so that the autonomous vehicle should handle all the training. So this will come over the time. It will not come the over time. So whenever it faces new challenges, you will know that, and you will try to add that in data. So that way we will reduce bias. So the baseline model, the baseline algorithm will not be that efficient. So over the time, I think we can reduce the bias with training more data. And to address the ethical issues and challenges, I still feel that's a problem in whichever technology you take. It's not particular to the computer vision. So it can be using some guidelines or PDPA guidelines or GDPR guidelines. You can handle those issues.
Okay. Next question. Next question is from Chetan Habur. Hi, Chetan. How are you? Are you using clarification algorithm to build that? And I don't know why.
Might be classification.
Classification it should be. So,
yeah.
Yep.
So, I don't know what what you're speaking about, what topic we're talking about there. But yeah, generally, like if we actually want to look at a cat or a dog and say which one is that, we use actually a classification algorithm using multiple features across and say this is a cat or this is a dog. Yes, it's one of the ways.
Yep. So Chetan, if you're online at the moment and watching us, then please in the comments mention what exactly are you talking about, which particular use case you're talking about. But anyways, Abhinay, you want to add to that?
Yeah, like Aruna said, so it's a basic algorithm. So we, whenever we are identifying different parts of the picture, if we use the classification to identify, so it could be the object detection algorithm, but the primary one is the classification. So you have to identify whether this is cat or dog or what else. It's a kangaroo, something like that.
Okay. Next comment is from Mervin in the SAP Experience Center. He's saying, Dr. Nick, President. Hey, thank you, Mervin. Thank you for the comment. But Dr. Nick is left, so you can call him. Next one from Samuel Victor, and he says, hi, Samuel, once again. And he says, what are some of the free computer vision and AI technology available that can be leveraged for simple business processes? You want to go first?
Yep.
Aruna?
Yep. So there are lots of open source frameworks, right? We have TensorFlow, PyTorch, and all these open source frameworks which are already there, and they have availability of multiple languages, whether you want to code in Python or C++ or whatever. So that will be the starting point to choose what frameworks you want to work on. Yes, simple business process. Yes, we can do that. And also, like the most important thing in AI, whether it's computer vision or other things, is actually start with a problem, right? If you have a problem, instead of saying that we want to solve some problems with computer vision, start with a problem and see how you want to go about it. It's always with a problem.
Okay. You want to add to that, Abhinay?
No, it's like pretty much summarized what Aruna said. So yeah.
Okay. The next question is from Chetan Abor, and he's saying, being data scientist, how do migrating to AI? Don't understand the question.
Yeah.
Is it migrating a model to run that, or is it him migrating to AI? I don't know. So I'm a bit confused with the question. If you've got, Chetan, if you're still watching us, you have to clarify two of your questions you've asked. Please clarify, give us more details, and we'll take the question. We're still here. Okay. Next, Sujit Ramesh says, thank you for your answer. And then Sujit comes up with another question, and he says, how efficient can be computer vision in dark or dim light? And that's a very interesting question. Who wants to take it?
Yeah.
Abhinay?
So the computer vision can handle the dark light as well. So nowadays, there are some researchers are going on how to, if you take the image in the dark and you can, using computer vision, you can see what it is actually there if it is not dark. So using the technology, you can actually handle all this dark and dim light. You can do some pre-processing, and you can enhance the image, and you can handle those problems over there.
Okay. Aruna, you want to add?
No, I'm good.
Okay. Good stuff. Let's go to very quickly to LinkedIn and see what are the questions around there at LinkedIn. So on LinkedIn, I've got the first comment from Kiran Nanduri, and he says, hi Kiran, how are you? And he says, hi Shailendra and all. Hi Kiran. He says, any use case of SAP with computer vision scenarios in offering? I think Abhinay, you want to
Yeah. So, like I said, I can remember one case in agriculture. So we have one of the customer from Malaysia. They have to do in a palm tree acre. So they want to find. Currently, what they are doing is they are actually sending each person every day to multiple person every day to go through the palm tree places and find which fruits are ripened. I mean, which tree is ready for harvesting for that day. So using computer vision, using drones, you can actually, instead of, you don't have to send person, it will actually go and it will mark the trees for you to harvest on that particular day. So this is a very good example where I see which can reduce a lot of manual work, and it's quite efficient as well. And at the same time, while scanning the tree for while scanning the fruit for whether it is ripened or not, it also capture the leaves in the trees and finding whether what kind of nutrition value that have, whether it needs to be whether we have to give certain medicines to that plants or not. And one other example is irrigation. So which we don't have to irrigate the entire area. You can do the segmented part of the area to irrigation. So it's implemented in that also. So these are the technologies where SAP is implementing. This is I know. And some other technologies like for the retail, for the shopping, you can actually do the visual makeup whenever you're buying something in e-commerce. You don't have, if you are buying some lipstick or whatever it is, you don't get the chance to wear and see whether this color suits you or not, right? So in that case, a computer vision, with the help of computer vision, you can wear the makeup and you can see in the camera whether it suits you or not, and then you can decide whether you want to buy it or not. So the another example I'll say is the e-commerce.
Okay, Aruna, I will not let you go without asking the other side of the question. Is there any offering from Dell that you want to share?
So these solutions with the computer vision or AI are very, very specific to each industry and each customer. And we do work with a lot of customers, and like Abinaya was mentioning, agriculture is one of the areas where we can do precision farming, and we are working with manufacturing clients to detect the defects in the products, and also maintenance, like Nick was mentioning, the utilities companies. How do we actually see if a particular bolt is loose or something on a particular power pole, right? How do we actually see that maintenance? These are all really complex for humans to go and do this, and predictive maintenance, right? Looking at all these things and doing the maintenance only when it is necessary, not like a regular pattern of doing it every 6 months or 4 months. And the other one I could think of is actually train tracks. How do we manage and maintain these train tracks, right? We normally have, we have these buses, and it's a lot of schedule and lots of things, right? They might not need maintenance at that particular time, but they might need it a little later or a little earlier. How do we know that? We just having a camera on the train and capturing all this data on the tracks, on the images or the video from the tracks actually can really help. There are actually plenty of use cases. They're very, very diverse. Each customer is very different. So I would say it's not a particular offering, but we do have a platform to build these solutions. And we work with a lot of partners like SAP to get to the end of or the business outcomes.
Okay. Next question, next comment is from Subhranshu Shekhar. And Subhranshu says, that's a good computer vision use case, and he was mentioning to one of the use cases from Dr. Nick. So, hi Subhranshu, how are you? And thank you for the comment. And then finally, Karthik Polraj, and he is influencer relations and digital marketing. And he says, first of all, hi Karthik, how are you? Very relevant roundtable. No doubt computer vision is the rising tech. And he has also mentioned a link to an article which talks about computer vision and the rising of tech post-coronavirus. So, thank you, Karthik, for sharing that link, and hopefully everyone will have a look at it. Guys, I thank you very much for being here. It was a pleasure having you. Apart from a couple of technical glitch which we had with the bandwidth of internet at some point in time, but otherwise it was working perfectly fine. Thank you very much for your time, girls. And if you want to say something to your audience, this is your time. One thing you want to say to your audience. I will start with Abinaya.
So reach out to us whenever you want, like we can help you with use cases or computer vision implementation.
Okay.
Reach out to us.
Aruna?
Yeah. So as I said earlier, start with a problem in mind, right? Don't do these technologies just for the sake of doing them. Think of a problem which you want to solve, and then we can actually, like Abinaya said, we're always here to help you. Reach out to us if you need any help with the use cases or how do you have to implement them.
Thank you.
Thanks for the opportunity, Shelly.
Thank you very much. It was a pleasure having you both along with Dr. Nick, and which was funny with the computer on his face. So thank you very much for being here, and I'll see you guys later.
Yeah. Bye.
Thank you.
So that was Aruna and Abinaya, Aruna from Dell and Abinaya from SAP, along with Dr. Nick from SAP, who discussed and explained various use cases, technology, and how computer vision is going to change our lives going forward. So if you want me to discuss any such topic, then please mention that in the comment section. And if you think you want to hear from one of the leaders in this space, in the emerging technology space, please mention their name as well in the comment section, and I'll try to get them here. Guys, thank you very much for taking time out and watching the show. It was a pleasure having you. Please like the video, comment on it if you've got anyone to add to that list of leaders that you want to see. And finally, please smash the follow button and the subscribe button on YouTube so that you can be alerted when a new show is on. Thank you very much. Thank you for your time. Bye now.